Hello everyone. So this is the first lecture for your artificial intelligence syllabus for your GATE DA exam. So this is just an introductory video for your AI syllabus. So as you can see our syllabus, there is a search algorithm topic. So this video will cover the foundation for the particular topic. Okay. So we are going to discuss what is search problem and what are the different terminologies used in that. So this video will act as the overall foundation for your AI course. So one thing I want to know is your feedback regarding this video. So after watching this complete video, please comment below with your education background and feedback for this particular video. Right. So I want to know if you are from different background. So what is your understanding of this particular topic? Right. So that will help me for further lectures. Right. So let's start our first video, that is for AI course. Okay, so intro to AI. So we are not going to discuss like what is the definition of AI or how it is evolved, what is the history of AI. Not all those things. That is not important for the gate point of view. But in general, when we talk about the AI, so we usually think about this particular AI human robot, right? So it will act like a human, it will perform a task like a human, like what we do. So this is AI human robot. So what is AI? So AI covers a range of techniques that appears as sentient behavior by the computers. Okay. So for example, you must have seen about self-driving car, right? Self-driving car. We just have to select our destination and self-driving car will take us to that particular destination. Right? And for example, you must have seen recognize face in photographs. For example, in Facebook post, when you post a group photo, so Facebook will suggest you, okay, this person is this tag him, right? This person is this particular name, right? Tag him. So this suggestion that Facebook will give. So it is all based on AI algorithm. Now, now you must have seen the news also where AI beat the world champions in the chase, and also the common example like Alexa, Siri, so, so Alexa Siri will give us the instant response. So they will process what we have speak, and according to it, they will give us the response. So this is just a AI introduction to AI. So I hope you understand what is AI. These all are the examples of AI, not just this humanoid robot, right? This is also part of AI. Recognizing faces in Facebook and photograph, that is also AI, right? So small thing can also be a part of artificial intelligence, right? So now let's start with the search. So what is search? So what do you understand by a search, right? So basically searching is what? Finding something. Search is referring to a finding a solution to a particular problem, right? So search means basically a finding a solution to a particular problem, right? So if we are given any task to a particular AI robot or any AI algorithm is to perform some specific task. So search algorithm will help you to finding a solution to that particular problem. Right? So for example, you must have used our Google Maps, right? So Google Maps navigator that find the best routes from your origin to a destination. Suppose if you want to go from Pune to Mumbai, right? So Google Map will suggest you three routes, right? So three routes. So out of three, he will recommend you. So out of three, Google Maps will recommend you one route because this will take less time, right? So how this telling us, okay, if we go by this route, it will take less time. So first, it will calculate on the distance. Second, it will calculate on the traffic, right? And also nowadays, Google Map will also suggest, okay, so this work in progress on this particular route, so it will take longer time. So how this Google Map is predicting best route, recommended route for us. So it's also part of AI algorithm only, right? Now, next example is playing a game, right, and figuring out the next move. So we are going to look at this particular example in this video. Okay. Now search. Simply, suppose I want to go from Mumbai to Pune, right? So AI will suggest me three routes, one, two, three routes. So out of three routes, which one is the shortest route, right? Which one will take the minimum time? So that AI will suggest, right? So that's the part of AI algorithm. Okay, so that's what we are going to discuss. Okay, now let us have one AI robot, say AI player. Okay, we have AI player, and now this AI player is going to play one game, one puzzle game. Okay. Okay, now this is a puzzle game, right? So we have to start from here. We have to find a way to escape this puzzle and we have to come from here, right? So what is the first task what we'll do here? So first thing is that you should know what is your entry point, right? So you should know what is your entry point. Then you should know what is your exit point, right? And you should know what are the actions you have to take. Okay, like this, like this, like this. Right? So you should know what are the actions you have to take. And those actions must be in a particular sequence, right? Those actions must be in a particular sequence, right? And it's not like that if you're taking actions particular sequence, you will reach this particular goal, or you can say exit point. Okay? But we have to also find out the path it will take, the path which take minimum time, right? Which take minimum time, right? Some cost should be minimum, right? So it's not like that I am just entering this point on Monday and after 1 year I'm coming from this particular exit point. No, so we have to find out the minimum path to so that we can so that I can approach this particular exit point, or we can is our goal, right? So that's the basic thing. So that's thing from the search. Okay, so now let us take one search problem here. Here also we have this beautiful AI player. Okay, now she is playing this game like puzzle game. So we know we have already played this game, like it's a 15 puzzle game. So we have to shift this particular tiles like up, down, left, right, like this. So we have to convert this particular state into a required output. So what is the required output here? 1, 2, 3, 4, 5, 6 till 15 in a particular sequence, right? So this is our output, right? So this is our initial state. So this is our initial state, and this is our final state, right? And this is our basically a goal, right? Now this AI player will play this game. So this is our initial state which is given to her. Now what AI needs to do? First, he should know what are the possible actions he can do, right? He or she can do. So whether she can move this particular one down, 10 left, 6 right, or 15. Whenever the AI performs a particular task, whenever we will perform this particular task, we'll get a complete new state, right? So suppose if I move this particular 10 here, this 10 here, right? So this will become empty, right? So then this state will become a new state here, right? So this is our initial state. Now this state will become a new state. Now in this way, what we have to do, we have to do complete actions. We can move this up, we can move this up, this left or right. So we have to do different iterations to go to this particular solution, right? But the thing is that we should take minimum steps, right? So our goal is not to reach this particular final state, but we want to reach this particular goal state at the minimum steps, right? That's what our efficient algorithm will be, right? So let's try to understand this search problem with the help of different terminologies using this search problem, right? Okay, so first one is an agent. So what is an agent? This is just an entity, any entity that perceives its environment and acts upon that environment. Okay, this is just an definition, or you can say an entity that perceives its environment and act upon that particular environment, right? For example, in our Google map, like navigator map, you can see agent would be representation of a car, right? That needs to be decide on which action to take to arrive at the destination. Okay, suppose this is point A, this is point B, and this is our three routes. Okay, so I want to go from point A to point B by self-driving car. Okay, by self-driving car. So in this case, my self-driving car will be a agent. So now this car needs to think, okay, what are different actions I should take to reach this particular point, right? In a particular sequence, and also with the minimum time. So that is what agent will do, right? Okay. So now what is state? So configuration of an agent in its environment. So whatever the action agent will take, based on that particular action, it will reach to a particular state, that is new state, right? Suppose for example, this is our initial state, right? Initial state. Now I am taking one action. I am moving this particular tile on the left hand side, this here, right? So this tile will come here. So this will become empty. So this will become my new state, right? So state is basically any particular given configuration of an agent in this particular environment, right? So for example, you can say in 15 puzzle, state is any one way that all numbers are arranged on a particular board. Okay, so I hope you understand what is state here. right? Now, what is initial state? Initial state basically the state from which our search algorithm starts, right? So this is our initial state. This is what we have discussed in the previous slides. Now, what is action? When AI algorithm know, okay, this is my initial state. From this state, I need to start my searching, right? So, what are the possible action that particular AI can take? Okay, so that choices that can be made in a particular state. So, for example, if you see the AI has four choices, right? AI has four choices. First one is that he can move this 10 tile right on the right hand side, sorry, left hand side now, or one tile down, or this block number 6, this 6 blocks right on the right hand side, or this 15 on the upward, right? So there are four possible actions that particular AI can take, right? So what, right? So more precisely, actions can be defined as a function. So basically, action can be defined as a function for that particular state. Upon receiving a state S is a particular input. So actions can be defined as a function, right? So it will return as the output of a set of action that can be executed in particular state. Okay. So whatever the action that we need to perform, we need to define it, right? So that will give us a new state, right? Once we do that action on this particular state, so we get a new state, right? So I hope you understand what is action here. Just a choices that AI can be made. So what are the possible actions that AI can take for a particular given state? That's it. Now what is transition model? So here you can see once we given a particular state as an action A as an input. So we have a particular initial state, right? We have different blocks like this and action A as an input. So suppose for example in the previous slide, the input is move this 10 on the left hand side, right? So this result functions will act as a transition model. So basically S will be your my state and A will be your my possible action that I will going to do on this particular state. So I will give a so I will get a completely new state, right? So that basically a transition model. So for example, given configuration of 15 puzzle, state S moving a square in any direction, so action A will bring to a new configuration of a puzzle. So whole process can be considered as a transition model. Okay, so I hope you understand what is transition model. We'll also going to discuss one example. Now here you can see this is a result function. This is our state S, and this is what I am doing. I am moving this particular tile on the right hand side, on this side, right? So this is an action. This is my state, can be any state, and this is a new state, right? When I am performing any action on a particular given state, so I will get a new state, right? So that is what a transition model is. Okay, so I hope you understand what is transition model. Same here, you can see I can move this down also, and I will get a completely new state here, right? So that's what transition model is. Okay, now state space. Now you must have learned about sample space in probability, right? So what is sample space? Like all possible outcomes, right? All possible outcomes. For example, I am rolling a die. I am rolling a die. So what are the outputs? What are the possible outcomes? 1, 2, 3, 4, 5, and 6, right? These are the possible outcomes. So this we can say as a sample space for this particular event, rolling a die. Right? Now what is state space here? Similar to that, the set of all states reachable from initial state by any sequence of actions. The set of all states reachable from initial state by any sequence of actions. So for example, in the initial state, there are four choices, right? Now what we are saying, what is state space is the state of all state reachable from the initial state by any sequence of actions. For example, the 15 puzzle, the state space consists of 16 factorial by 2. So there are 16 blocks, right, in the particular puzzle. So how many state space will be there? So it will be 16 factorial by 2 configurations, right? So this is what state space is. I hope you understand what is state space, right? So any doubt in this part up till now, you can just comment below, not an issue. I will try to make a separate video on that in a detail because this is just a introductory video. Okay. When we perform some tasks or actions on any particular state, so this is my given state as I'm doing some action A, I'm getting this new state. Again, I'm performing some tasks, I'm getting this state. Again, I am doing some action. Again, I am getting new state. Okay. So in this way, I can get a new state, right? So it may be possible that in this particular puzzle, I will just end it up with a particular loop like this, right? So this can be also possible. Now what I'm going to do, I'm going to convert this particular problem in a graphical model. Okay. So now state space can be visualized as a directed graph with the states represent as a nodes and actions represent as arrows between nodes. Okay. So this will be my nodes and these actions will be my arrow. Okay. Okay. So this is, you can say this is my states. So this is action. Once I perform this action on this particular state, I am getting a new state here. Right. So I'm converting this particular problem in a graphical way. Okay. So we have converted the state space, this one, into this particular state. Okay. So nodes will represent a state and arrow will represent an action. Right. Now, once we start with this, suppose we are starting with this. So we should know like which one is my goal, whether I want to find, whether I want to reach here, 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 or here, right? I should know what is my destination. I should know what is my goal, right? So now let's see what is goal test is. The condition that determines whether a given state is a goal state, right? So algorithm should know, okay, I have reached this particular condition or this destination, so this is my goal state, right? So this is our final goal, right? For this particular 15 puzzle problem. Okay, so I hope you understand the goal test. Now what is path cost? So basically, it is a numerical cost associated with a given path. Okay. So if I take that particular example of a graph, I want to reach from node A to F. So I can go by multiple path, right? So that time, that particular length, I can consider as a numerical cost associated with a given path. For example, you can say a navigator app does not simply brings you to your goal. It does so while minimizing the path cost, right? So Google Maps will recommend you, okay, this is a recommended route. It will take a less time, right? Also, the finding the fastest way possible to you to get to your goal state, right? So this is the main objective of finding out the path cost. See, for example, this is our entry point, that is my node C, and suppose I want to go here. This is my goal. Okay. So I should know, okay, if I go by this route, I will take this much time. If I go by like this, right? So graph travels, so it will take this much time. If I go by this route, it will take this much time. So what will be my path cost for each of the path? And out of which is having a minimum path, so that will be my optimum path, right? So I hope you understand what is path cost here. So for a given problem, for 15 puzzle problem, the path cost for each action is 1, we can say, right? Either we can move the tile up, down, left, right, anywhere, right? So the cost associated with this particular problem, 15 puzzle problem. So that's what we have discussed, right? Not every problem will have a same cost associated with particular actions. So some problem will have more cost, right? If we go by this path, it will take 2 units. It will take less unit if I go by this. So total C to E. If I want to reach this destination E from C, so it will take C D E. That is 1 plus 6. That is 7 here. So if I go by C H F, sorry, C H E. So what? How much time it will take? 3 plus 2. So basically that is 5 units. So this is my minimum from this two, right? So that's what we have to find out. What is our optimum path? So what is solution? A sequence of actions that leads from initial state to a goal state. So what are the actions that we are going to do from initial state to reach our particular goal state, right? That is the solution, but that is not the optimum solution. Our optimum solution is that the solution that has the lowest path cost among all the solutions, right? So this is a simple way. I hope you will understand. Now, this is the few things that what we have discussed in the search problems. So what is initial state, what is action, what is transition model, then goal test and path cost function, then solutions and optimal solutions. Also we have seen what is agents, right? So please remember this terminologies. It will be very useful for the further lectures. Then whatever we have discuss today. So please comment below your feedback along with your education background. Okay. So this is just a foundation for your search problem. So I hope you understand in a detail. So I have just tried to explain in a simpler way by taking one example. Okay. Yeah, so I think that's it from my side, but I want to know your feedback for this particular video along with your education background. Okay, yeah, thank you.